Welcome to the Defense and Aerospace Report. I'm Vago Muradian here in Tampa, Florida, where we're covering the National Defense Industrial Association's annual SOFIC Conference and Trade Show, one of the world's leading gatherings of special operators and the companies that serve them from around the world. Our coverage here is sponsored by FLIR Systems, and we're over here at the Hughes stand, an EchoStar company, I should remind everybody, but still one of the most legendary names in defense and aerospace, to talk to Jeff Lessner, who's a Senior Director for Business Development. Former NASA guy before you went into industry and went into a very historic company that delivered the first communications satellite, if memory serves correctly, even though that part of Hughes is over at the Boeing company. Talk to us, Jeff, a little bit about what are the top priorities you have with your special operations customer? You know, we've been hearing about the need for greater connectivity from just about everybody. We talked to Jim Thomas, who is the, Jim Smith, who is the acquisition chief. I transposed the names there. Jim Smith, who's the acquisition chief, about the importance of secure communications, things that can resist electronic warfare that potential adversaries will be directing against us. What are the top things you're talking to the customer with?
Well, Vago, here at Hughes, our primary function is to provide that connectivity and the secure communications for the special operations community. Through our work with Waveforms, we've come up with a kind of a unique waveform that allows communications below the noise floor. Basically, one of the things that has been identified by the major combatant commands is the ability to be hiding in plain sight. We've gotten many briefings from NASIC, who takes care of the threat conditions facing the satellite community, and their number one sort of advice to us was if they can't see you, they can't jam you. So we've come up with a waveform called Scrambled Code Multiple Access, SCMA, which has the ability to do high rate data communications with operations under the noise floor, so that an enemy combatant cannot see the signals, and if they can't see them, they can't jam them. We did a number of experiments at Trident Spectre, which was a naval surface warfare experiment over the last 2 years in Virginia Beach, Virginia, and we were tested under various conditions for the ability to see our signal and the ability to jam it, and we came out, the reports are actually classified, but I can say we came out with flying colors on that.
And talk to us a little bit about the space and who else is in this market. You guys have invested money in this technology. You guys think you're the leader. Who are the other competitors in this space, and what do you think gives you the advantage in a place where a lot of other folks are competing?
Well, not to get too technical about it, but the waveform is actually code-based, which allows it to the spectrum to be spread and the power reduced below the noise floor. SCMA is a code-based waveform. The other one that's popular is called CDMA, Code Division Multiple Access, which is actually used by a number of companies in the field. However, they have some very serious technical difficulties that don't allow them to work in a very numerous, if you will, a lot of operators in the same location.
In a crowded piece of spectrum.
In a crowded piece of spectrum, exactly, because they have problems what's called near field, far field, which is a power control problem. One of our competitors has fielded a system into the Army that's having some problems because that there's some soldier that's very close to the receiver, it's very loud, that interferes with the other guys. Our system, by the other hand, actually takes advantage of these differences in power to take care of the first most powerful signal first, then cancel it out and go on to the next. So we actually look for differences in power. I don't believe there's anyone out there right now who has this capability, and has been implemented to the effect that Hughes Network Systems has done it so far.
The entire space and your piece of space, or the business space, has been radically changing. Everybody wants to drive down the cost of military communications. The satellites were very expensive at one point. Hughes, Boeing, Lockheed, a lot of the companies that have made satellites have benefited from it, but we're now in a very different era where you have the SpaceX's of the world, Blue Origin moving into that space as well. You have Virgin Galactic. We visited with them a couple of, about 2-3 months ago out in California. They're looking at changing the game, not launching from a mothership, a modified 747, and everybody is talking about smaller and smaller and smaller satellites to ease that access to space. How is that changing the game, given that you guys have operated in this business in a very different environment than the environment that we're going into now?
Well, it's a paradigm shift for sure, and it all really revolves about lowering costs. The government, unfortunately, doesn't, I believe, want to be in the business of launching satellites, simply because of the cost of the launch, the cost of the insurance, the cost of the satellite itself, and the time frames involved for the government to conceive a satellite, design a satellite, build a satellite, launch a satellite. Could be a decade or more, where commercial is launching satellites almost on a 3-year basis. At least we are at EchoStar and Hughes. So you take the time, the time dilation for the government to actually fund launch and get in operation a satellite, and the technology advances that go forward. That commercial is really the way to go, and we've been informing the government through their analysis of alternatives, which is an operation that's being held by the U.S. Air Force Space and Missile Command, as to how they can best use commercial launch operations and commercial satellite broadband communications capabilities. The other paradigm is, in fact, the proliferation of small sats, but small sats are advantageous in the fact that they cost less, they're more numerous, and they have lower latency, but they sometimes are lacking in actual total capacity, if you will. So the geo belt where EchoStar and Hughes operate now are larger satellites, but we're talking in the aggregate rates of 600 gigabits per second. Where a small sat may do a gigabit per second or a couple hundred megabits per second. So that is one of the problems with the small sats. Okay.
Horsepower matters sometimes.
Horsepower matters, and also the tracking. These satellites are whizzing by once every 3 minutes. You need a much more robust antenna system to track more than one satellite at a time, which drives up the cost of the terminal system. In fact, Hughes is actually doing the infrastructure for the OneWeb constellation. I don't know if your readers were aware of that, but Hughes is under contract to provide all the gateways, the hubs, and the infrastructure to run the new OneWeb, which is an 848, I believe is the number now, LEO constellation.
Which Airbus is going to be producing the spacecraft.
Yep.
A couple of years ago we talked to Tom Enders, the CEO, on the morning that announcement had been made,
right.
And he was very, very excited and still remains very excited about the program. You've been in the space game for a long time, in the communications game for a long time. How, as you look to the future, how is this market going to be evolving? When you look 5 years out, or maybe even 10 years out, what are some of the changes that the entire community, military, commercial, are going to see? When you put that hat on and you rely on your 3-4 decades almost of experience in this field and look forward 10 years, what do you see?
Probably more than anything else, I think that the way we've been operating in the past has been very stovepiped. Hughes has a network, iDirect has a network, Viasat has a network, Intelsat has a network, everybody has a network. And these networks are non-cooperative and they don't communicate with each other. Other than at the IP layer, at the Internet Protocol layer, what we're seeing now is a trend for not only for cost reductions, but also to fill a need of the SOCOM community and the combatant commands for resiliency and redundancy. As we get into the next decade, and God forbid a war with more of a peer adversary, we're going to see the need for resiliency, redundancy in satellite communications, and the only way to do that is to have multiple paths for communications. Hughes Network Systems has just been funded by the Air Force for a thing called Pilot 2, which is part of this analysis of alternatives, to take a look at how we can coexist across multiple networks, software controlled with a thing called flexible modem interface, which would take a Hughes modem, a Viasat modem, an iDirect modem, with somebody else's modem, and have them coexist, and then at the software layer decide through a rule-based engine or a cognitive management system which is the best path to take. So if I wanted to call you and you were in some place in the world, we could choose a Hughes network or an iDirect network depending upon quality of service, redundancy, resiliency, at least latency, possibly lowest cost, highest reliability, things of that nature, so that the satellite communications and wideband industry becomes more homogeneous to the end user, and they don't have to worry about, oh my God, I'm on this network or that.
There are a lot of historic names. I'm going to ask you a little bit of a history question.
Sure.
There are a lot of historic names in this room. Obviously, Lockheed and Martin and Boeing, and you have Raytheon and Northrop and Grumman. But Hughes is also one of the giant names, which was through merger and acquisition activity sort of broken up, and the company is different than it is now.
Yeah.
But what are the things that inspire you about the history of the company as somebody who works there? I don't know. I know people who work in Northrop who are utterly passionate that they came from the Northrop side of the company or they came from the Grumman side of the company. They buried the hatchet and seem to get along just fine now. But Lockheed and Martin had very, very different cultures when they were going through it. And then you had Hughes, which was visionary founder. You don't get more eccentric and visionary than Howard Hughes, and a company that had a reputation for being innovative at each and every step. It's a wonder that parts of Hughes ended up going into parts of Raytheon, given that each one of the companies looked at the other as sort of the enemy. Talk to us a little bit about, when you think about the history of the company, what are the moments and things about it that you find sort of inspirational?
Well, all the firsts. I mean, Hughes was the first to, as you had already mentioned, was the first geostationary satellite, going way back when in 1950s, I believe. 1963, I think was the exact date. We've been a number of firsts. We fielded the first VSAT. We fielded the first VSAT for commercial use via Sam Walton and Walmart, for him to do his basically his order operations for the rural stores he had all over the world that weren't covered by infrastructure at the time. These waveforms, we invented the DVB-S2 broadcast waveform, which was to a large part a Hughes operation. We're very open in our standards. We don't hold anything as complete IP. We're just a good partner. I mean, and our engineering staff is par none as far as their depth and breadth, and and experience in the business. I think one of the inspirational things I've found as I've been with Hughes is that most of 100 people I talked to, probably 30 or 40 of them worked for Hughes at one point in time, and now they work for Raytheon, or they work for Boeing, or they work for News Corp, or they work for DirecTV, all of which were Hughes, Hughes inspired and spun off companies. I guess nobody really knows that we started DirecTV at this point. Then we spun that off to Rupert Murdoch, obviously now part of AT&T, and Hughes is now part of the EchoStar Corporation, which is the parent company of Dish TV. So we're still in the TV business after all those years. So it's kind of interesting.
And then I forgot to mention the General Motors link, right? Because you were GMH, which was Hughes, a Hughes company. And I remember when I used to cover you guys, I would also cover the car sector, because the automotive part had a meaningful impact on whatever it was going to have on the defense elements of the General Motors company. Let me ask you one last question. Space is becoming a very, very contested space, no pun intended. As you when you said that you're working on proprietary waveforms to ensure connectivity, to allow units to hide in plain sight and yet still be able to communicate, but the big concerns are the safety of the safe space infrastructure that we now have from kinetic means. There is an appreciation that everybody has that in the event that a shooting war opens up in space, it's going to be bad for everybody, so let's not do that. We talked to General Hyten, the debris from that Chinese ASAT test is still up there at a very, very bad orbital altitude, and folks have to steer around that debris field, the International Space Station. That's always a concern. But also then the jamming, the lasing, all the other technologies that folks want to apply. Talk to us about the safety of the space infrastructure, and how to safeguard it, how to assure that space access at a time when potential adversaries are working very, very hard to disrupt it, whether through brute force jamming or through kinetic means.
Kinetic means there's not much we can do other than have numerous satellites and spacecraft to choose from, and that was the idea, at least initially, for OneWeb, was that there are so many satellites up there. From a commercial point of view, they weren't worried about resiliency and protecting space. What they were worried about was technology insertion. A satellite would only have typically a 5-year lifespan before it was deorbited. So every 5 years they could renew their constellation, if you will. For a military point of view, it's important in that, if a satellite is taken out in higher Earth orbit, the LEO satellites are still going to be okay. Obviously, with the lower the orbit is, the quicker the debris field will clear as well. But if you got 800, 900 satellites up there, which one are they going to shoot? And your ability to then change to another satellite. This flexible modem interface also is helpful in that we can now, choose between what satellites are operational and what satellites are not operational in, say, the geo belt. So I don't believe kinetic is going to be the way to go, like you said, because if it hurts us, it hurts everybody. I think it's going to be more, electronic warfare, electron beam type things where they would target a satellite and take it out. And with our ability then to change constellations and change satellites and networks, we could evade that in that manner. Also, one of General Hyten's, priorities is space situation awareness. So we want to have a fleet of satellites that is aware of its environment, specifically for those satellites that are maybe vulnerable to snugglers, or a satellite that would go up and knock it out of orbit, or that sort of thing. So the ability for a satellite to have some freedom of motion, if you will. And we've been in talks with some companies who are doing exactly that. They have more propellant on the craft so that if they see something coming up, they can move out of its way, for example. Or the addition of electro-optical and other sensing devices, say radar or electric optics, so they know that a threat is coming up and they can avoid it that way as well.
Jeff Lessner of Hughes, sir, thanks very much. It was a real pleasure, and look forward to talking again, and thanks very much for all the time.
Thanks, Vago. I appreciate the time.